So, say again?
You got 31.
Oh no, good, am I? Good, thank you. It's actually because it's in the cell below, which is the 31st cell. That's actually okay. Did you hear what Amaya said? And this is a good point to remember. The way the TI numbers things, whatever cell you're in is that place in the list. So when I entered the last one, 0.493, which is this guy down here, I'm actually in the 30th, and then when I pressed enter to enter it, it kicked it down to the next blank space, so then you're in the 31st space. So we're golden there. Now, we could answer a similar question. I mean, one thing, did anybody think of it as, how many of those burritos were under half a pound?
About 5.
1, 2, 3, 4, 5, 6, 7. 7 of them. What percent are under half a pound? Answer this question carefully. What percent are under half a pound? Or over half a pound, whatever you guys want to, whatever one.
23.
So 23 out of 30 are over, 7 out of 30 are under. Answer it carefully. If I was to ask you what percent of, now that was in the sample, yes? What percent of Del Taco half pound bean and cheese burritos are under half a pound?
We don't know because we don't have.
But can you give me a 95% confident answer? Hint,
Yes.
hint, hint. Of course you can. What do you got to take your 7 over 30 and do with it? Well, you already divided it, 7 out of 30. What do you have to attach to it? Which was the whole point of last week. You got to put a margin of error on it, yes? Right. I'm trying to give you a hint by saying, give me a 95% confident answer. If you tell me it's 7 out of 30, I go, 0% confidence. Put a margin of error on that. So we can answer a related but not the same question by running a confidence interval. This doesn't even use the data you just entered. If we do a 1 prop z int, just as a quick reminder from last week, 7 out of 30, which would be, this is the percentage of those that are under half a pound, yes? 95% confidence. I am 95% confident that somewhere between 8 and 38% of Del Taco half pound bean and cheese burritos are under half a pound. That's a hell of a margin of error, isn't it? What is that? What is the margin of error on that interval? In percentage points?
30.
Well, it's 30 wide, so what's actually the margin? Remember, that's 2 margins of error. 1 up and 1 down. So it's actually 15, isn't it? 15 up, 15 down, which makes it 30 overall. Remember, p hat plus or minus the margin of error. So that's 15%. Why is it so freaking wide? Didn't we say that 3% was pretty good last week? Because our sample has 30 in it instead of like 300 or 3,000. Right? You start increasing that guy exponentially or even linearly, and that margin of error is going to start shrinking. So there's your 7 and 30, 23%. There's your 7 out of 30. But you really should, you should with any kind of statistical study, as inane as this might be, slap a margin of error on that. But that's not the question I asked, did I? I asked, on average, how much does it weigh? So in other words, I don't care the fact that 7 of them are below half a pound. I want to know what the average, assuming this is a good random sample. Now, is it? Is it a good random sample? Probably not. I went to the same store every week. The only thing I truly randomized, because chances are, I never looked every single time, but the same people were behind the counter each time too, for the most part, the times I remember to check. The only thing I randomized was how many from my 4 I was counting in this until I got up to 30. In order to get a better study, I'd have to get the Del Tacos all over the country, randomly select those. Don't have the budget for that. So hopefully you can let that slide with this and just say it's okay. It's okay? It's okay. Ish. So, how much does it weigh? We've got our data in L1. Thank you, Veronica, for the idea. What should we do with it now that it's in L1? What do you guys think?